Okay, let's talk about some derivatives some people struggle with. Now, these two derivatives I'm going to cover in part 1 of this video, and then this other one here, this really nasty looking one, I'm going to cover in part 2. So, the first one, let's look at it. ddx of x squared. This is a polynomial. It follows the power rule. Most people don't struggle too much with this rule, and basically you pull the exponent down and it's 2 times x to the first. You subtract 1 from the exponent, and there it is. Now moving along to this one, okay? The most common mistake people will make in the beginning on this one is they'll treat it as if it were the power rule. They'll bring the exponent down and they'll say x times 2 to the x minus 1, and they're following a rule. But you got to remember that rule only applies for polynomials, so you can't do that in this case. Here's what you need to do. When I do this, I say y is equal to 2 to the x. What I can do is I can take the natural log of both sides. Hope you like my natural log. And now what I have is the natural log of y is equal to, now one of the properties of logarithms, and this isn't a derivative, this is just a property of logs, is that the exponent can come down and out front. So it becomes x times the natural log of 2. Now don't forget, the natural log of 2 is just a constant. So when I differentiate this, it's sort of like differentiating 5x, because natural log of 2 is sort of like 5 in that regard. It's just a constant. So what I'm going to do is I'm going to ddx the left. I'm going to take the derivative with respect to x of the left, and I'm going to ddx the right. Okay, so the derivative with respect to x of the natural log of y, I have to do that implicitly. So that's 1 over y times the derivative of what's inside y, which is dy dx. Leave in the comments if you want to see something done on implicit differentiation. And that's equal to the natural log of 2. In the same way the derivative of 5x is just equal to 5, since natural log of 2 is a constant. Now I'm going to multiply both sides by y, and I get dy dx is equal to y times the natural log of 2. But don't forget how we started this discussion before we took the log. Y was equal to 2 to the x. So what I have is dy dx is equal to 2 to the x, because that's what y started out as, times the natural log of 2. Okay, now see if you can pause the video and do the derivative of x to the x before I do it in the next one. But I want to point out, if y were equal to e to the x, dy dx is actually equal to e to the x times the natural log of e. But we don't need to write the natural log of e since it's 1, but technically it's always been there.